for every single atom, it's going to contain three species: protons, neutrons, and electrons. When we actually talk about this atomic symbol, a general expression of atomic symbol, typically you have something called the atomic symbol X. And then at the lower left corners, you have Z. Top left corner, you have A. So the X is called the atomic symbol. Z is called the proton number. A is called the mass number. So if you have an atomic symbol, you're going to see the proton number at the bottom left, mass number on the top left. We just mentioned that for atoms, it was actually made out of protons, neutrons, and electrons. So let's think about the mass first. This actually tells you the mass of the proton, neutron, and electrons. Compared to the proton and neutrons, you should be able to see that the mass of electron is extremely small. Basically, the mass of your atom is contributed from the sum of neutron and proton. Okay, so that's constant number one. Constant number two is for atoms. For most of the time, if you don't see a charge written on this atomic symbol, it will be neutral. So when you say neutral, it means actually you're going to have the same amount of protons and electrons. If this atomic symbol you see, if you don't see anything like Mg2+, if you don't see this guy, there's actually nothing here, right? That means actually the atom you are looking at, it is neutral. That means actually it has the same amount of electrons and protons. So that's actually the second thing that you should know. Third thing that you should know is that the atomic symbols is determined by the proton numbers. So what do I mean by that is that if you look at your periodic tables, you see these numbers on the top. What those number means is actually telling you how many protons that specific atom has. For example, your hydrogen has 1 proton, lithium has 3 protons, okay, potassium has 19 protons. In other words, if I tell you I have an atom that has 37 protons, then you should be able to know the atom I'm talking about is this Rb. If I ask you to write out the atomic symbol, that's the things you should actually come up with. Once you know the proton numbers, you know what elements on the periodic table I'm talking about. Every time you see the proton numbers, you should be able to actually identify the atomic symbol by yourself. So let's actually the constant number 3. Get back to here. If today I give you atomic symbols, can you actually figure out the number of protons, number of neutrons, and even number of electrons inside this atom? Okay, there will be actually something you're going to get tested in this chapter. Let's look at this. You have the magnesium 2412. How many protons do you have? 12, right? Because the bottom left corner, it always give you the information about number of protons. How about the number of neutrons? So if you look at the atomic mass of proton and neutrons, they are pretty much the same weight. In other words, these things on the top, we call it as mass number. So mass number is going to equals to the number of protons plus the number of neutrons. So with that concept in mind, then you know, since the number of mass is 24, your number of proton is 12. Therefore, you can figure out the number of neutrons. It's going to use equals to 24 minus 12. It's going to give you a value of 12. So what's the number of electrons here? 12, right? Because it's neutral, right? You have 12 protons. Therefore, you're going to have 12 electrons. So this is actually the questions they're going to ask over and over again in this chapter. But the key is actually always looking for the proton number first. Then you will know how many protons you're going to have. And then by comparing to the mass number, you're going to know how many neutrons you're going to have. By comparing the overall charge of your atom, you can actually also figure out how many electrons you're going to have. Another type of question you're going to see from here is actually just the opposite. If I tell you the number of protons, number of neutrons, and number of electrons, can you actually give me the proper atomic symbols? Going down to the next slide, we want to actually calculate the atomic mass and the atomic weight. One very important concept you have heard for a long time is actually so-called the isotope. So what is isotope? Isotope was defined as atoms with the same atomic number but different mass. So atomic number is actually the things at the bottom left corner. It's actually also your proton numbers, but have different mass. One of the most famous example is actually the carbon. So we know the carbon is typically you have 6 protons and the mass number is actually 12. I guess you also heard of carbon-13 and the carbon-14. You can see for all these 3 different atoms, the proton number in these 3 cases, they are all equal to 6, 6, 6. So the proton number are the same, but the mass number, they are different. That means actually the neutron numbers, the carbon-12, you have 6 neutrons. Carbon-13, you have 7. Carbon-14, you have 8. This actually makes calculating the molecular weight of carbon very interesting. Because right now, you have different isotope, right? But when you want to actually report the molecular weight on the periodic tables, you need to consider all of them. In nature, you have roughly 80% carbon-12, around 15% of carbon-13, and 5% of carbon-14. To actually really calculate the molecular weight or the formula weight of carbon, what you do is you get the atomic mass of this multiply 0.8 plus this times 0.15 plus carbon-14 times 0.5. So this will be ultimately how to calculate the atomic mass of atoms. So from here, you should be able to see the number you got will never be an integer. Okay, so if you look at your periodic table, so you see the molecular weight of carbon is 12.011. So that 12.011 is actually the average result when you actually consider all the molecular mass of the isotopes. And then you can see actually pretty much every single atom, they have its own corresponding isotopes. In order to actually get the numbers on the periodic tables, you really need to know the relative abundance of different isotopes so you can calculate atomic weight of each atom. So that's how we actually define the atomic mass of an atom. So with all the things being said, I want to actually go through a couple of examples. Example number 1, if I give you one atomic symbol and I want to ask you, okay, there are how many electrons, protons, and neutrons in this atom? Again, the first step is actually always look out the proton number, right? How many protons you have in this case? 54, right? Then the number of neutrons can be calculated from your mass number minus your proton number, which is going to equal to 132 minus 54. That's going to give you a number of 78. So you can figure out your number of neutrons through this simple relationship. How many electrons you have? Number of electrons equals to 54, right? Because it is neutral, right? So you know number of electrons equals to 54. Question type number 2, given the chemical symbol including the subscription indicating the mass number of the ion with 22 protons, 26 neutrons, and 19 electrons. The first information you're looking for is actually the proton number. So the proton number is equals to 22. Then what you should do is actually go to your periodic table looking for the symbols with atomic number of 22. which will be titanium, right? So you know the atomic symbol has a form like titanium-22. What is the mass number? So we know the mass number is basically just the sum of your protons and the neutrons. The proton you got is 22. Neutrons you have is 26. Therefore, you got 48, right? So you put 48 on the top left corner. The very last one is actually about the charges. You have 22 protons, 19 electrons. What will be actually the charge? So the number of protons minus the number of electrons, they will give the formal charge of the elements. Okay, so number of protons here is actually 22. Okay, electrons is actually 19. Therefore, you got positive 3. So that will be the answer you're going to input